In today's Evolving Things chapter, we're taking a stellar journey through the evolution of the telescope. How did we go from observing the stars with the naked eye to exploring galaxies far beyond our own? Our journey begins before the 1600s, in an era when the concept of the telescope as we know it was yet to be realized. Ancient and medieval scholars, with their eyes on the stars, turned to ingenious devices to unravel the mysteries of the celestial sphere. Among these early instruments were the astrolabes and quadrants, not telescopes in the modern sense, but critical in their own right. Astrolabes, with their intricate moving parts, allowed users to measure the positions of the sun and stars, becoming indispensable tools for navigation and timekeeping. Entering the 17th century, a pivotal chapter unfolds in the story of astronomical exploration. In 1608, Hans Lippershey, a Dutch eyeglass maker, ignites a spark across Europe by filing a patent for one of the earliest known telescopes. Imagine the excitement of seeing farther into the heavens than ever before. Just a year later, in 1609, Galileo Galilei takes this nascent technology further, enhancing the telescope to achieve about 3x magnification initially, and later up to 30x. With this tool, Galileo brings the cosmos closer to Earth, offering a glimpse into the celestial wonders. 1610 becomes a landmark year as Galileo's observations shake the foundations of astronomy. He unveils the moons of Jupiter, the phases of Venus, and the moon's rugged terrain. By 1611, the quest for clarity brings Johannes Kepler into the fray. He introduces a telescope with a convex objective and a concave eyepiece, significantly enhancing image quality. Soon after, he refines this design further with the Keplerian telescope, featuring both convex objective and eyepiece, vastly improving the field of view and image clarity over Galileo's model. As we navigate from the 17th to the 18th century, the story of the telescope enters a chapter filled with refinement and groundbreaking discoveries. In 1645, Marin Mersenne introduces the aerial telescope, an innovative approach featuring very long focal length objective lenses without a tube. This design significantly reduces aberration and weight, solving two major issues of long refractors. By 1663, James Gregory envisions the Gregorian telescope, a type of reflecting telescope designed for a wider field of view and free of chromatic aberration. In 1668, Isaac Newton revolutionizes telescope technology by inventing the reflecting telescope. His design uses a mirror to gather light, effectively reducing the chromatic aberration common in refractors and marking a significant leap forward in optical science. The first practical reflecting telescope, based on James Gregory's design, is finally built by John Hadley in 1721. This model improves upon Newton's earlier versions, proving reflectors' viability for astronomical research and paving the way for future explorations. Then, in 1781, William Herschel's discovery of Uranus using a telescope of his own design astounds the world. Stepping into the 19th century, we enter a period of profound technological advancements in telescopic exploration. Between 1838 and 1845, a monumental achievement in telescope design is realized by the Earl of Rosse. He constructs the Leviathan of Parsonstown, a colossal 72-inch reflecting telescope. Imagine the awe of peering through such a giant as it reveals, for the very first time, the spiral structure of galaxies. In 1845, the significance of the Leviathan becomes even more apparent. Its use of a speculum metal mirror represents a leap forward in reflecting telescope technology. This material choice for the mirror pushes the boundaries of what was possible, enhancing the telescope's ability to capture faint celestial light and providing astronomers with clearer, more detailed views of the cosmos. The 20th century marks an era of large telescopes. monumental structures that extend humanity's gaze far beyond the confines of our planet. In 1917, the Mount Wilson Observatory unveils the Hooker Telescope, a 100-inch behemoth that claims the title of the largest operational telescope in the world. Its unparalleled view of the cosmos sets the stage for one of the most groundbreaking discoveries in astronomy. Just a few years later, in 1930, the Hooker Telescope plays a pivotal role in Edwin Hubble's discovery of the expanding universe. This revelation, that galaxies are moving away from us in all directions, fundamentally transforms our understanding of the cosmos. By 1948, the quest for deeper cosmic insight leads to the creation of the 200-inch Hale telescope at Palomar Observatory. As the new titan of optical astronomy, it pushes the boundaries of what we can observe, bringing distant galaxies and nebulae into clearer view. The space age dawns in 1962 with the launch of Ariel 1, the first British satellite. Among its instruments is an X-ray detector, marking an early, ambitious step into space-based astronomy beyond the optical spectrum, opening new windows onto the universe. In 1977, astronomy takes to the skies with the Kuiper Airborne Observatory. This modified C-141 aircraft, equipped with a 36-inch reflecting telescope, pioneers infrared observations above most of the Earth's atmosphere, setting the precedent for future satellite-based infrared observatories. The pinnacle of this era arrives in 1990 with the launch of the Hubble Space Telescope. Positioned beyond the distortions of the Earth's atmosphere, Hubble revolutionizes our view of the universe. Its high-resolution images unveil the beauty and complexity of space, from the birthplaces of stars to the very edges of the observable universe. The 21st century marks an era of unprecedented advancements and ambitious future projects in the realm of telescopic exploration. Between 2006 and 2009, the world witnessed the construction and operation of colossal ground-based telescopes like the Large Binocular Telescope and the Gran Telescopio Canarias. Equipped with adaptive optics, these telescopes overcome atmospheric distortion, offering clearer views of the universe. In 2003, the launch of the Spitzer Space Telescope expanded our cosmic perceptions into the infrared, revealing aspects of the universe invisible to optical telescopes. Following in 2008, the Fermi Gamma Ray Space Telescope embarked on a mission to explore the universe's most energetic phenomena in gamma rays. The European Space Agency's Gaia spacecraft, launched in 2013, is on a mission to create the most precise 3D map of the Milky Way, changing our understanding of our galactic home. And in 2018, the Transiting Exoplanet Survey satellite, TESS, took to the stars, its eyes set on discovering new exoplanets using the transit method, broadening our search for worlds beyond our solar system. The pinnacle of this century's astronomical endeavors is undeniably the launch of the James Webb Space Telescope, JWST, in 2021. Heralded as the successor to the venerable Hubble Space Telescope, JWST represents a leap forward in our quest to unravel the cosmos. Designed with the most advanced technology, this space telescope is set to observe the universe in infrared. JWST's mission is monumental. Equipped with a mirror over 6.5 meters in diameter, it promises to peer back over 13.5 billion years to observe the first galaxies that formed after the Big Bang, providing insights into the birth of the cosmos. Its ability to see through dust clouds with unparalleled clarity allows it to reveal the processes of star and planetary system formations, offering a glimpse into the cradle of stellar birth. That's a wrap on our journey through the telescope's evolution here on Evolving Things. If this voyage among the stars has captivated you, hit like, subscribe, and join us for more explorations. We've navigated a vast timeline today, yet it's possible we've missed details or weren't spot on with every fact. Noticed something? Drop us a comment. Your insights enrich our journey. Thanks for watching.